All right, so we're going to have a look at arithmetic sequences. We're going to look at geometric sequences and series. Oh, I haven't changed what the goals are. Oops, it's just as radical. Sorry.
You know you should post them on YouTube. You should post them on YouTube.
I do.
He does. You do. Breastness is YouTube.
I have a whole YouTube channel.
I'm gonna follow you.
I have a few followers. So they all go up onto YouTube. All right. I've got a couple of example ones for you to look at. We're going to write an explicit and a recursive rule for the given sequence. So have a look at that first sequence. Can you see what the pattern is? Figure out for yourself, what's the pattern in this first one? Take a minute. Sam?
It adds 7 each time.
It adds 7 each time. So how can we denote this? One of the things we want to do is each term in the sequence is given a specific term number. So this term here at the beginning, this would be A1 with a subscript. This is A2. This is A3. This is A4. This is A5. So these are the terms in the sequence. The sequences always start at term 1. Always start at term 1. So in order to do an explicit one or a recursive one, let's do the recursive one first. So the recursive definition, this is how you would do it recursively. A recursive definition needs 2 pieces to it at least. So you need to define what the first term in the sequence is. A1 is equal to 2. Recursively, you then show what the rule is. An, so the nth term in the sequence, nth term in the sequence. In this case, the nth term in the sequence is given by an minus 1 plus 7. An minus 1 is the previous term in the sequence. An plus 1 is the next term in the sequence. So each term in the sequence is given by the one before it plus 7. In effect, you're going through like this, plus 7, plus 7. And this is how we can define this rule. We need one more thing for this. This is a finite sequence. This is a finite sequence. What does finite mean? No. It's finite. It's not infinite. It ends. It ends. It's the opposite of infinite. So finite sequence means it finishes. How many terms are in this sequence? So to define this sequence, we need to say that n is between 1 and 5. And as is the case with all sequences, n is always an integer. N is always an integer. You can't have a 2.5 term in a sequence. It's not like a function. So it's always an integer sequence.
So why 5?
We counted them. How would we do it with an explicit one? So explicitly, there's actually a couple of ways we can write the explicit one, but the explicit one will let us go to the nth term in the sequence directly. We need to take the first term in the sequence, and then we need to add n minus 1 lots of the common difference. So the nth term in the sequence is going to be 2 plus n minus 1 times 7. So for instance, the first term in the sequence, we don't need to add 7 to it to get to it. We're already there. So the second term in the sequence, we need 1 lot of 7 added, which is hence the n minus 1. To get to the second term of the sequence, we need 1 lot of n. To get to the third term in the sequence, we need 2 lots of 7. We need to go plus 7 plus 7.
Times 7, sir?
Well, yeah, it's n minus 1 times 7, but we're adding. So for the first term in the sequence, we don't need any lots of 7 adding. We need this to be 0 and disappear. For the second term in the sequence, we need 1 lot of 7. So 2 minus 1 gives us 1 lot of 7. For the third term in the sequence, we need 2 lots of 7. 3 minus 1 is 2, 2 lots of 7, gets us to what we want. And then we go directly at any formula, any point. So if you're wanting the 15th term in a sequence, this formula is going to get you there in one step. This one's going to take a while. But the two concepts are useful in different ways. All right. The next one. Can you have a look at the next one? What's the pattern? Sorry, let me give one more word. What's important here, when we add a common difference, this is an arithmetic sequence. So if you add a common difference, to each term to progress through the sequence, that is called an arithmetic sequence. How about the next one? Discuss with the person next to you, what's the pattern? What's the pattern? Okay, so what is the pattern? What is the pattern? Multiply by 2. So for our recursive definition, what do we need to say? Excellent. A1 is equal to 3. We also need the rule. What is AN?
A is equal to A n minus 1 times 2.
A
N minus 1 times 2.
That's right. A n minus 1 times 2. How many terms in this sequence? Infinite. This is an infinite sequence. So how do we define n?
Greater than 1 and every positive integer.
Greater than 1. We could just define it without, couldn't we? N is any of the positive integers. You don't even need the greater than 1. That would be sufficient.
Why is it greater than 2?
Because it can be 1. We can't be 0. How about explicit? We need, I'll put the general formula up. I put the general formula there. It's useful for these ones. So we need the first term times what we call the common ratio, R. How many lots do we need? Is it n? N plus 1? N minus 1?
Minus 1.
Why n minus 1? We need n minus 1 lots of the common ratio, because when we, at the first term, we need to multiply by 1. So r to the 0 is going to be 1. We don't want to move. So we only want to move 1 forward through the sequence on n equals 2. So it's n minus 1 again. So this one, our nth term in the sequence is the first term times 2 to the n minus 1. Something else that will help you with this, is another formula for the common ratio. The common ratio, and the reason it's called the common ratio, it's given by an divided by an minus 1. So for instance, you can take A2 and divide it by A1, and you'll get the common ratio. 6 divided by 3 equals 2. You'll find this formula useful with harder ones. For instance, this one's easy. You can see the times by 2. But let's say the common ratio is 5/7. You ain't gonna see that so easily. You ain't gonna see that. So if you take one term and divide it by the previous term, you'll see the common ratio.
So is this an arithmetic sequence or?
No. So
Geometric.
this is geometric.
Why?
So an arithmetic sequence, you add a common difference. With a geometric sequence, you multiply by a common ratio. So let me get this in this, where am I running out of space? This is what we call the common ratio. And this is a geometric sequence. That is tons of knowledge thrown at you there. Let's have a go for yourselves. Have a go at these two questions. Have a go at these two questions.
Sir?
Yep.
About the IM cells,
Oh, hold on, let me. All right, let's have a look at these ones. So the first one, is it arithmetic or geometric? Who did this? Who did both? Put your hand up.
A.
Okay. Do the first. Is it arithmetical or geometric? Arithmetic. What's the common difference? Plus 3. So what's the recursive formula? A1 equals minus 7. AN equals plus 3. And how is n defined?
Every positive.
What about the explicit? AN is equal to minus 7. The second one, arithmetic or geometric? Geometric. What is the common ratio? So typically with this, I would start with 24 divided by 48 equals a half when we find it. So AN is equal to 48 times 1 over 2 to the n minus 1. Recursively, we've got A1 is equal to 48, AN is equal to AN minus 1 times a half, and n is, no, it's not. Where is n? N is an element of the set of n, which goes from 1, how am I going to write this? From 1 up to 1, 2, 3, 4, 5.
It needs a geometric, right?
So some notes for you if you need to look through when you're doing your homework. A sequence which there is a common difference is an arithmetic sequence. So U1 is U1, U2 is U1 plus 1 lot of the difference, U3 is U1 plus 2 lots of the difference, and we come up to our formula. A geometric sequence has a common ratio. We have our formula here. And these are the formulas how they look on the formula sheet that you'll get on the formula book. Those two formulas. All right, some problem solving. Have a go at this problem, see if you can solve it. Okay, so many of you were able to sort of solve that problem, but let's look at how to structure it a little bit better, how to structure your solution a little bit better. So if we're at U11, sorry, if we want U11 and we're at U6, how many lots of common difference do we need? 5. We need 5 lots of common difference. So we can put these in. We've got 34 is equal to 4 plus 5d. That means that d is equal to 30 divided by 5, which is equal to 6. If we're at U11 and we want to get to U15, how many lots of common difference do we have to add? 4. So U11 is 34 plus 4 lots of 6 brings us to 58. A little bit better structured. Notice my structure. Look how my equal signs line up on the page. This is something that a lot of you don't do. You move randomly around your page, making it impossible for the reader to follow what you're doing. When you get into a problem-solving situation, when you're doing a standard problem that you've been drilled on, you're okay. But as soon as it starts to get hard, then your structure goes completely. You start randomly writing things all over the page until you get your solution. So make an effort to try and work down the page in a straight, logical line. It should read easily. Often when you read my working on the board, it's easy to follow what I'm doing. Very well structured and organized. I don't move randomly around the page. Okay, let's have a go at another one. I was pleased then. I was pleased. Here, praise. There you go. Have a go at this one. Should have made this harder. I have to make it harder for the C class. They'll laugh at this. Yeah, why not? Don't get caught on this one. There's a trick here. I can put a landmine in it. Let me pause this a minute. So, if you're at U5 and you want, if you want U5 and you're at U3, you need to multiply by R and then you need to multiply by R again. So U5 is U3 times R squared. We can put our numbers in that we have. We have 81 and we have 36 multiplied by R squared. This gives us 81 over 36 is equal to R squared. Simplify your fractions. You're going to get 9 over 4 is equal to R squared. And this is where I nearly weep. Every time I come, we're looking at one of my fabulous students who I'm so proud of, and they manage to disappoint me greatly. What is this? What is R equal to if R squared is 9 over 4? Plus or minus 3 over 2 is possible at this point. Plus or minus. The simplest of things is forgotten.
Which class? C, no doubt, or whatever class A class A. Why is 36 squared 4? It's not 6.
What's 36 divided by 9? Okay, so now we need to decide, can it be negative and positive? Can it be negative or positive? Now, if it's positive, then all the terms will either be positive or all the terms will be negative. A positive is not going to change the sign. So if you have a geometric sequence and all of the terms are positive or all of the terms are negative, then it's positive. If you have a geometric sequence which alternates positive, negative, positive, negative, positive, negative, then you're going to have a negative. So if you multiply it by a negative, we'll change the sign every term. It'll be an alternating sequence. An alternating sequence has a common ratio which is negative. It will go plus, minus, plus, minus, plus, minus. So what you have to look at is here, how far apart are these? Both of those two terms are positive, but there's one missing in the middle, which means that could be positive or negative. We don't have any more information than that. Now, if I had the third term and the sixth term, and they're both positive, I would throw out the negative, because it has to be alternating terms. So if the third is positive, the fourth is negative, the fifth would be positive, and the sixth would have to be negative. So if I'd given the third and sixth, we have to throw away the negative at this point. It's going to alternate. As far as we're concerned, we don't know. So what we need to do now is we need to find U1. So U3 is going to be U1 multiplied by R squared. To get from U1 up to U3, we need two lots of R. So this gives us 36 is equal to U1 multiplied by plus or minus 3 over 2 squared. Now, it doesn't matter whether it's plus or minus because we're squaring it. So the first term also has to be a positive term, regardless of whether the common ratio is positive or negative. And if we solve this one, then we're going to get U1 is equal to 16. So UN, there's two possible sequences. UN is 16 times either plus or minus 3 over 2 to the n minus 1. And there's two sequences. And they will alternate.
Sure, it's impossible for us to discover if it's going to be plus or minus.
With the information given in this question, yeah. You could give more information in the question. I could say two terms of an alternating geometric sequence that has to be minus. I could say two terms of a positive geometric sequence has to be plus. I could give U3 and U6 and then indicate it that way. So we are going to do a little proof. This one's a fun one.
Oh, yeah.
I'm going to do this one for you. There's no way you'll do this without me. It's a useful proof because sometimes we use this technique in a few other places. So usually when you see this proof, you might be able to say, oh, I've seen a proof like this and how we do these types of proofs. So I thought I'd include it today. It's not too hard.
So the moment we disconnect us the moment I get a question.
That's good. Okay. Let me show you how I'm going to do the proof. So we want to find the sum. We want to find the geometric. It's called the geometric series. Or the geometric sum. That's when you add up all the terms in the sequence. This is an infinite sequence. This is an infinite sequence. Or a finite. Sorry, this is a finite sequence. Sorry, this is a finite sequence. It's because we know what n is. We know what n is. N is an infinite, so it's finite. There are n terms in this sequence. What is the first term in this sequence? A1. What is the second term in the sequence?
A2.
Can we define that in terms of A1? A1 times R. What is the third term in the sequence? A1 times R squared. Dot, dot, dot. What's the last term in the sequence?
A1 plus R times Rn.
Not quite.
Or n minus r.
A1 times R to the n minus 1. This is the expansion of the sum, isn't it? We can see all the terms here now. I'm going to take this equation and I'm going to multiply it by R. I'm going to take this equation, I'm going to multiply by R. I will get Sn times R. On this side, that term will become what? If I multiply all of these terms by R, A1 times R. So this term will become A1 times R. What about the second term? If I multiply it by R, what does it become? A1 times R squared plus dot dot dot. If I multiply the penultimate term, I get A1 times R minus 1. And if I multiply the last term, I get A1 times R to the n. Notice how when I multiply by R, each term in the sequence moves one space to the right. The first term becomes the same as the second becomes the same as the third becomes the same as the fourth, the penultimate becomes the same as the ultimate, and the ultimate moves out beyond the end. So, if I take this equation, second one, and I subtract the first one, so I'm going to take the second equation, and I'm going to subtract the first equation. What will happen on the right-hand side? Discuss with the person next to you. Think it through. What happens on the right-hand side when I do this? That's an R. Issa, why did you do this to me? That's it.
If it had broken, we would have serious words.
This was very serious. This was a precursor to the typing.
Right? Right. So what happens? What happens?
A1 plus A1 dash R equals
What happens? This, when we take this term and we subtract that one, it disappears. When we take this term and we subtract that one, it disappears. When we take this term and subtract that one, it disappears. So we're left with A1 times R to the n minus A1. Okay, we got a common factor on each side. What's the common factor on the left-hand side?
R.
S, A1, I, R.
B, C.
SN.
Hi.
10.
What is the common factor on the left-hand side? Carlos. There is no A1 on the left-hand side. Let me take somebody else. Let me take somebody else. I will pick on Mark. What's the common factor on the left-hand side? I will pick on somebody else. Let's have a look. Who's not said anything? Yes. SN.
That's what I was trying to say, bro. Honestly.
If we factor Sn out of these two terms, what are we left with inside the bracket?
Oh, Sarah, I thought you meant from the across the whole sun. So you're being more specific, actually.
I could not have been more specific than what is the common factor on the left-hand side?
Sarah, there's the equal sign.
Yeah, there's the left-hand side of the equal sign and the right-hand side of it.
Custom.
What is the common factor on the right-hand side of the equal sign, which is written on the bottom line of the page in front of you?
A is the common factor.
A is the
Oh my god.
A A is not the common factor.
Why?
Thank you.
What? Zero.
Thank you, smart students. Correct, my friend here. If we factor out A1, because we can't factor out A, we factor out A1, what are we left with?
Smart idea.
R to the n minus 1.
You know, if I didn't say that, if I didn't say it in front of my friends,
We're gonna call it Zeus.
that's my
Yours.
What have we managed to do?
Create the LHS and the RH, the sum of the two.
We managed to do the proof. I like that proof. It's one of the first proofs I learned to teach. I like it. I don't know, it's a nice proof.
Yeah, very nice.
I like it.
You know LHS and RHS.
There could be, if you wanted. All right,
What again?
let's find the sum here. Let's find the sum here. Do you want to have a go for yourselves, or do you want me to do it?
Oh, you can ask.
Oh, okay. I'll do it for you guys, but I'm pretty sure C will insist on having to do it themselves.
Sure.
Okay. What type of series is this? How do we know? It says in the question. That means it has a common ratio. What is the common ratio?
3.
Common ratio is given by 15 divided by 5, which is 3. What's the first term in the sequence? 5. How many terms in the sequence? There it gets a bit tricky, doesn't it? So, what is the nth term in the sequence? What's the formula for the nth term in the sequence?
Okay, I solved it.
5 times.
So that's 405.
Actually, he solves
5 times 3 to the power n minus 1. I didn't solve
So, the nth term is given by this. If we want to know what n is, and we put in 1, 2, 1, 5 is equal to 5 times 3 to the n minus 1, we need to solve this. So if we divide 12, 15 by 5, what do we get? A little bit more. You can use your calculator.
Oh, we have to use the lower.
I mean, 12, 15 divided by, we're not paying. How can we solve this using our calculator?
Why are we trying to solve for n?
N solve. N solve this. N solve this.
Why would you solve?
You want to know N? That's how many terms in the sequence.
But it's fine.
Sure, there's 5.
Oh, it's easy.
I mixed it to a.
Oh my god.
What do you say? There's 5.
I just answered my own question.
That's right, right.
Is it just well, it's actually
Okay, let me come around and see it on your calculator. You see it on your calculator? You see it on your calculator? Oh, good. You see it on your calculator? Excellent. Good student. Let me see you solve it on your calculator. Wait, is it solved in your equation? Let me see you solve it on your calculator. Let me see you solve it on your calculator. You see the good students. Which ones are not worthy?
I do not think so.
Which student you are worthy of the place of the reference?
So I have the calculator.
You are not to bring a calculator, which is not. No. You were a much bigger problem that you couldn't do. I need to see you start to use this tool. Let me see who's worthy.
And solve the option.
You are not.
It's so easy. No, it's true. Put it into
All right. So this gives us n is equal to 6. So we want the sum of 6 terms, which is a1 multiplied by, what's our r? R is 3 to the 6 minus 1 over 3 minus 1. Type this into your calculator, see what we get. You don't need to end solve it.
Why is
Type the
why is
formula in.
it squared?
So I'm gonna win is
Yeah, that's what you know how so what is your one is a1 times r squared minus 1.
Wait, so what are we trying to do?
Because 1, 2, 1,
Oh, the sum.
squared.
Oh, yeah, you don't put that in.
Makes more sense.
No, because you.
What do we get?
No. You guys are collaborating with somebody here in the classroom.
All right, can we stop the chatter? Stop the chatter. Focus.
Oh my god.
I'm not doing this again.
I'm going to run through this one for you and show you. So, no, this is sigma notation. I'll show you how sigma notation works. Oh. So to expand, can we stop the chatter, please? To expand this, we are going to have, firstly, n will equal 1. We'll put that into the formula. We'll get 2 times 4 to the 0. And then we're summing it. So then n becomes 2. We get 2 times 4 to the 1. Then n becomes 3. We get 2 times 4 to the 2. And then n keeps going up until we get so when n becomes 7, we'll get 2 times 4 to the 6. So how many terms do we have? 1, 2, 3, 4, 5, 6, 7. We have term 1, 2, 3, 4, 5, 6, 7. 7 terms in this. So we can calculate each one of those and add it up, or we can find out what the sum of 7 terms is. What's the first term in the sequence? 2. What's the common ratio? 4. How many terms in the sequence?
7.
Calculate this on your calculator.
Why did only 4 months?
Did you pay any attention to the formula when we proved it?
Yeah, but
R minus 1.
Yeah, I know, but I know you figure out why.
R is 4.
Oh. What's 2 times 4? So the first thing is 2. What?
How do you make the 7 on the board?
It's 1092. What's 44?
Okay, can we stop the chatter? Can we stop the chatter? So what we need to do is we need to put this into the calculator. Let me show you how to do it here on the board. We need this. We've got 2 times bracket 4 to the power of 7 minus 1 over 4 minus 7. Sorry, 4 minus 1. And this gives us 10,922. Okay, let's have a look at the formula here. When we see the formula written like this, you can see the first term in the sequence and the common ratio. Because look, this is A1 times R to the n minus 1. This is telling you the geometric sequence formula. That term there is exactly in the same pattern as this formula. U1 times R to the n minus 1. This is U1 times R to the n minus 1. So we can pull those up, put them into the geometric sequence formula. I would like to practice doing that when you do the IXL on this. But you can also go another way. So take your calculator in your hand now. Press menu, choose calculus, choose sum. We get the formula. We can type it in and it starts off at 1, it goes up to 7. We've got the formula 2 times 4 to the power of n minus 1.
So we're allowed to use that in the test.
Yes,
That's like a whole answer.
that is the word. Be warned, with the IXL activities where you get these, don't just use that. You won't learn as much. Practice finding out what the first term is, what the common ratio is, what the number of terms is, and putting it into the geometric formula. The reason being, when it comes to a test, I might give you a question like this and get you to find the sum, but I might give you part A, part B, part C. Part A is what's the first term in the sequence? What's the common ratio? How many terms in the sequence? What's the sum? You will not know how to do parts 1, 2, and 3 if you only use this. Okay, have a go at doing this one. What is the first term? What's the common ratio? How many terms are in the sequence? What's the sum?
So we can know it directly just by looking at it, right?
It's a little harder. Let's have a look. What is the first term in the sequence going to be? 4. So the first term is when n equals 0. So you'll get 1/4 to the 0, and then you're going to get the first term. So A1 equals 4. What is the common ratio? We can see that fairly easy. That's 1/4, because every time we're timesing by multiple lots of 1/4. The n is going to go 0, 1, 2, 3, 4, 5. It's going to keep time going 1/4. The hardest thing is how many terms in the sequence? 6. Because it starts at 0 this time. Last time we had 7 terms in the sequence, it started at 1. But this time it's starting at 0. We have 1 extra term. So it goes 0, 1, 2, 3, 4, 5, 6. Well, 6, yeah. So n is equal to 6. So we want the sum of 6 terms. So we've got the formula 4 times 1/4 to the 6 minus 1 over 6 minus 1. Put this into your calculator.
So isn't it over?
Is it 1/4 minus 1?
It is. It is. Good one. Good one. 1/4 minus 1. And what do we get when we put it into our lovely calculator? Carlos.
1,365 over 2.
1,365 2 oh over 256 like this. Does anyone else get this number? Good. As long as a couple of people get it, I'll trust you. All right, last one. Excellent, nicely timed. Problem solving. We got. Have a go at this.
I assume we had the same one in our previous.
Sorry?
I assume we had the same question.
Maybe. It's a paper. We like bacteria, bro.
Yeah.
It's a good thing you can use. It is.
Guys, it's actually pretty easy, I think.
Stop is so bit.
So, a little bit of an applied problem here on this one. What's the first term in our sequence? So A1 equals 200. What type of sequence is it? Arithmetic or geometric? Geometric. What's the common ratio? Okay. So, what is the formula for the nth term? It's going to be 200 times n minus 1. How many terms in our sequence?
12. Infinite. 13 infinite.
This is where it gets a little tricky.
It's infinite.
It's
It's
13.
infinite.
So it's 0 minus 200, and then there's 12 times there's 13.
This is tricky. It's actually 13.
Exactly.
So every hour you get 3 new ones. So at 4 hours you get 12. But you still have the one when there's 0 hour. There's 0 from it. So it's a little trickier in that respect. And sometimes with these type of problems, when you're working with them with years and stuff, you struggle with this. I always like to actually draw like a timeline or count on my fingers because I mess it up after usually. You've got to forget that first one or not. So we need the 13th term in the sequence, which is 200 times 2 to the 13 minus 1. And that, I think it was 8,000. 819,200. All right, take your calculator in your hand. Hopefully I can do it on the one on the board. I know it gets a bit tricky, but I'm going to show you some more advanced tools here.
Wait, so 819.
Take your calculator in your hand.
Sounds exciting.
Take your calculator in your hand.
So is that the
Yeah.
All
All right, follow me through on this one. Sometimes the selection doesn't work well here on this one because I have to use the touchpad. So what I'm going to do is I'm just going to think through the problem using a spreadsheet. I wanted to check, did I get it right this morning before the lesson? And what I did was I sort of visualized it much better. So I'm going to click Control, Add Page, Add a Spreadsheet. Okay, so the time starts off at 0, doesn't it? To this, I'm going to do all the sort of time. So I'm going to take equals over here on the left, and then that cell, notice each cell has a column and a row. So the column heading and the row heading. So that first cell is A1. The cell I'm in at the moment is A2. It tells you there at the bottom, you're on A2. So I want cell A1. So I say A1. And to A1, I'm going to add 20 minutes. That will give me this. This next bit doesn't work so great sometimes here. So what you need to do is you need to press Control, Select, and then you scroll down like this, add loads of them, and then click. I've added a bunch of them. So Control, select, scroll down, and then you can add a bunch of them. So here on this row, I'm going to figure out, I wanted to be really lazy. I just didn't switch my brain on first thing in the morning. How many hours is that? So I can work out how many hours it is by taking A1 and dividing it by 60. So this will tell me that is 0 hours. I'm going to copy this formula down. I press Control, that bit in the center. I drag down like this. Come on. And I'm just doing loads of rows. So I get to about there. So, I want the 13th term. The 13th term. I got a bit lazier. I wanted to solve the problem. So we start off with 200. And then here I can say equals, and that one is C1. So equals C1 times 2. And then I see the whole progression as it builds. So I take that one and I copy this one down. Press enter. There's my answer.
So what is 240 mean?
Sorry?
What is it 240 mean?
Minutes. How many minutes? So this is minutes.
You can't put it.
You have to be careful not to use a keyword like min because it's minimum. This is hours. And this is bacteria. All right, that is it for today. So, wait. Before I say that is it for today. So what, I've given quite a few worksheets. You don't need to work through all of the worksheets entirely. What I suggest you do is you do the 4 IXLs, and then you go through the 3 worksheets and you pick 2 word problems from each, and do at least 2 word problems. That should be enough. On the worksheets, there's lots of questions about final recursive and explicit formula, so this or that. So you don't necessarily need to do all of those and stuff. So mostly what I want you to do is to do the IXLs and to do at least 2 word problems from each worksheet. You can do a couple more if you want.